Miss Robinson, your third grade math teacher. And the past few weeks, we have been going over multiplication and division strategies, right? That was super fun. It was brand new to us. And don't worry, we will get back to that in a few weeks. But right now, what we're going to do today is we're going to go back a little bit to when we were doing addition problems. And we're going to take a step further and work on two-step addition problems. So let's read our objective today. I can add using a number line, pictorial form, standard form, to solve two-step word problems. So we're going to use a couple different things to help us solve two-step word problems with addition. We're going to use a number line. We're going to use pictorial form, which we use for everything, right? We use that for everything. And standard form, because we do want to know how to add using just our numbers. The pictorial form and the number line, they'll just help back up what we already know. So great. So what I want us to do is we're going to kind of do things a little differently than we normally do. Instead of writing them on these pieces of paper and on the board, for me, working on word problems, that's a lot for me to be going back and forth, right? Back and forth and writing big. So what we're going to do is we're going to transfer over to a different camera. And you guys are going to work with me through some problems. So hold on just a sec. Just a little warm up for us to work on. I just want you guys to make sure you hear me very well. Sorry. I have 713 plus 298. And there's so many different ways I could go about solving this, right? So many. But we're going to go over the few ways that we talked about that we were going to do today. So first, I always like to do pictorial form first. Always, always, always. So I am going to represent both of these numbers in a place value chart in pictorial form or picture form. I see I have a ones, tens, hundreds, ones, tens, hundreds. And now what I'm going to do is I'm going to make a nice place value chart. I want to make it big so we can see everything, but I also want enough room to do the other strategies. So I'll probably do my hundreds right here. Can you see that? Yes. Leave lots of space. My tens right here, leaving lots of space. And my ones right here. I'm going to do a line so I know that this is the area that I'm going to draw it in. So for 713, I'm going to look at my hundreds place. I have 7 hundreds. So I'm going to draw 7 hundreds. 1, 2. Remember, 100 is just represented by a square. 2, 3, 4, or a triangle for a square. These kind of look like rectangles, but you know what I'm supposed to be doing. 4, 5, 6, 7. All right, so I got the 7. Now I have 110. We just draw a little line to represent our flats, or not our flats, I'm sorry, our rods. And so I got that. And 3 ones. 1, 2, 3. Excellent. Now I'm going to add 298. So I'm going to draw 2 hundreds. 1, 2, and I could do a plus sign to show that I'm adding. 200. 9 tens for 90. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so I got that. And 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Now I'm just going to add them. When I'm adding or subtracting, I always start with whatever is the smallest place value, is worth the least. And we can even just tell by these pictures, these circles are a lot smaller than the rest of everything else. And ones are, for us, ones are going to be the smallest place value. We don't deal with parts of numbers or decimals or anything like that we do in 4th grade. In 3rd grade, we just start with our ones. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wait. Do I remember what happens when we get to 10? When we get to 10 ones, we create 110. We're going to add that 10 over here, and we'll start over. We have 1 left, so I have a 1 in my ones place. Now I'm going to count my 10s. I include that one I added. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I stop. When I get 10 tens, I bring it over here, bring another 100, right? 10 tens is equivalent or the same as 100. And then I see I have 1 left. 1. Okay, so I have a 1 in my tens place. Now let's add our hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can either write 10 since I have nothing over here, or I can put 0, and I can turn those 10s into 1,000, right? And 1,000 is a square with the line behind it to make it look three-dimensional, and I have 1 of those. So, wow, this number has a lot of the digit 1 in it. 1,011. Now let's check using a number line. There's a couple different ways about going about this. Like, you really could do a lot with a number line. We've used it for addition, we've used it for subtraction, we've used it for all sorts of things. With this number line, I'm going to be adding. I'm going to make a nice big number line. And when I'm adding, to me, it seems easiest if I start with that bigger number so that I don't have to add as much. So I'm going to start at 713. I need to add this 298. So I'm going to break 298 up into like easy to work with things. Well, I see I have 200, right? I see I have 200. So I'm just going to kind of put off to the side 298, and I'm going to subtract away like whatever I'm adding so I know that I've added it. I know that 200, well, I can skip count by hundreds pretty easily. I could add 100 plus 100 would be 813 plus 200, right, another 100, be 913. All right, so I can subtract the 200 away that I've done. I know I have 98 left now. Now I could skip count by tens, right? How many tens are in 98? How many tens? I see I have 9 tens. So there's a couple things you could do. I want you to look at this and think about what strategy you might use. So some of us who are really, really good with figuring out where our numbers are might be able to look at this and say, oh, 98 is almost 100. Couldn't I add 100 then subtract 2? You absolutely could. But some of us, we are still trying to understand numbers a little bit better because we're just in 3rd grade, and 3rd graders are very smart, but sometimes we do need to take our numbers apart a little bit more to understand them, and that's okay too. So as a 3rd grader, I might say, well, I think I'm going to skip count by tens 9 times to see where that takes me. And that's what I'm going to do. So I'm going to do 1, 2, 3, 4, 5. I'm going to need a bigger number line. We'll see where this takes us, and then we'll continue down here. I've never had to continue a number line before. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So let's just skip count. 913, 923, 920, I'm sorry, 33, 943, right? I'm just skip counting that tens place. 953, 963, and I'm going to start right here at 963 where I left off right there. It's just a continuation. 973, 983, 393, 1003, right? 990 plus 10 more will be 1000. So now I've taken 90 away. I just have 8. So what I actually think I'm going to do is I know 3 is 7 away from 10. So I'm just going to add plus 7, and I'll have 1010. Well, minus 7, I have 1 left. I can just add 1, and I will have 1011. Okay, so these answers match. Let's do it in standard form real quick just to prove that we did it correctly, and then we can move on. So we have 713 plus 298. I need to make sure my numbers are lined up. 8 plus 3, 8, 9, 10, 11. I bring my ones place down here and regroup to the tens place when we get 10 ones, right? That's what we did over here. Now I have 9 plus 1 is 10, plus 1 is 11. I do the same thing. Put that 1, I bring that 1 down, and then I regroup to the hundreds place. 7 plus 2, 7, 8, 9, plus 1 more is 10, and I can get the same number. All right, so what we're going to do next is we're actually going to work on a two-step word problem. All right, so let's turn the page to this word problem. Well, there's a lot on here, but I promise you we're going to take it apart and it's going to be super easy to solve. Sarah, Kim, and Adrian all brought candy for their class. Oh, that was so nice of them, wasn't it? Sarah brought 79 pieces of candy. Kim brought 24 pieces of candy. Adrian brought 56 pieces of candy. How many total pieces of candy did Sarah, Kim, and Adrian bring for their class? All right, before I do anything else, I've read the question once. Now I'm going to underline my question and maybe make it a little bit easier into a sentence so I know what I'm looking for. How many total pieces of candy did Sarah, Kim, and Adrian bring for their class? So instead of writing all that down, I'm going to write, I like to write the letter of their names because some of these names are easy and some of them are hard. Sarah, Kim, Adrian, those are kind of easy, but I'm still going to say S, comma, K, Sarah, Kim, and A for Adrian, brought blank pieces of candy, right? We don't have to expand out on it. We just need a basic sentence so we know what we're doing. Now this time when I read it, I'm going to take it apart and I'm either going to highlight or circle some important things I feel like is in the problem. Sarah, Kim, and Adrian all brought candy for their class. Sarah, so I know I'm dealing with Sarah here, brought 79 pieces of candy. I'm going to write that down. Sarah, or S, equals 79. That's how many pieces Sarah brought. Kim brought 24 pieces. So K brought 24. Adrian brought 56 pieces. And we want to know how many they all brought together, their total. So let me write Adrian brought 56 pieces. And I want to know the total. Right? I don't know that. That's a question. So I'm going to represent this first by using a strip diagram. A strip diagram because a strip diagram is going to show us what operation I want to use, right? Operation means add, subtract, multiply, or divide. I want to really know that I represented this problem so I understand what to do with it. So with a strip diagram, we use 2 lines and a good chunk of it, right? One of the lines is usually equals the total being used. It doesn't matter if we're multiplying, dividing, adding, or subtracting. These work with problems where we have a total. We're looking for the total pieces of candy. Total candy, right? But we don't actually know the total. We do know that the total is being broken up into 3 parts that Sarah, Kim, and Adrian brought. So I'm going to put this into 3 sections. S for Sarah, K for Kim, and A for Adrian. Sarah brought 79, Kim brought 24, and Adrian brought 56. If I know that our total is those 3 parts together, I want you to think, what operation should I use? If you said add, you are correct. We want to add those 3 parts together to figure out the total amount of candy. 79 plus 24 plus 56 equals blank. So I like to use 2 strategies to prove my answers right. One strategy, the first strategy I'm going to use for this problem is pictorial form, or a picture. I will make for here, I only see ones, tens, ones, tens, ones, tens. But I'm going to add a hundreds place just in case I have to regroup because those are some pretty big numbers. So I'm going to put it off over here. I have a hundreds place that I'm not going to have anything in yet. Tens and ones. And I want to make sure I have lots of space. For 79, I have 7 tens. 1, 2, 3, 4, 5, 6, 7. I like to double check my work. 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I have 24. 1, 2 tens, and 4 ones. 1, 2, 3, 4. And then I have 56. So 5 tens. 1, 2, 3, 4, 5, and 6 ones. 1, 2, 3, 4, 5, 6. Now I'm just going to start adding. Remember, whenever I get to 10, I'm going to regroup it as a, once I get 10 ones, I'm going to regroup it as a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well I have 10 there. I'm going to add another 10 in. I'll use blue to show it's the one I'm adding, but it doesn't matter. Now I'm going to start over. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 ones. 9 ones. Now I'm going to count my tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tens equals 100. So I'm regrouping that, and now I'm counting the rest of my tens. 1, 2, 3, 4, 5. I have 5 tens and 100. So it looks like it might be 159. I'm going to double check my work by using standard form. I'm going to use standard form to add it together. I'm going to first add 79 plus 24 because those are the first 2 numbers. I don't like adding too many numbers together. I'm going to zoom in so you guys, sorry guys. There we go. 9 plus 4, 9, 10, 11, 12, 13. So I'll put a 3 here, add my 1 up here. 1 plus 7 is 8, plus 2 is 10. So I'm in the hundreds now. I have 103 by adding 79 plus 24. 103 plus 56. 6 plus 3. Well, 6, 7, 8, 9. Okay, that's looking good so far. 5 plus 0 is 5, and 1 plus nothing is 1. 159 matches our numbers. So the answer is Sarah, Kim, and Adrian brought 159 pieces of candy. Look at how we solved this. Look at all this work we did. It wasn't a very hard problem, but we were able to use these strategies to help us. Let's try one more. I'm going to give you guys a little bit of time to actually work on the next one too. Ben and Julio collect Pokemon cards. Ben has collected 134 Pokemon cards. Julio has collected 275 more cards than Ben. How many cards have the boys collected together? All right. So when we say the boys have collected together, we want to know their total, right? So let's underline this. How many cards have the boys collected together? So we could say B for Ben and J for Julio have collected blank cards together. All right, I'm going to read it a second time, and I want you to see if you can figure out what is important for us for solving the math of this problem. Ben and Julio collect Pokemon cards. Ben has collected 134 Pokemon cards. Julio has collected 275 more cards than Ben. How many cards have the boys collected together? So what you should have said is, well, we need to know that Ben collected 134 cards and Julio collected 275 more cards. So we have Ben. We know exactly how many Ben collected 134. For Julio or J, we don't know exactly, but we do know it's 275 more than Ben. And we want to know that they're together or their total. So this is going to be even more of a two-step problem because first we need to figure out how much Julio has. So before we can even solve to find the total, we need to figure out how much Julio has. So I'm going to draw a strip diagram to represent Julio. We know that Julio has more. This strip diagram looks a little different. This one has one that's kind of shorter and one that's longer. We know J, which is Julio, has the most, right? If he has more than Ben, he has the most. That's why his section is the biggest. We know Ben has 134, but we also know that Julio has this much more than Ben, which happens to be 275. So this is representing 134 plus 275. I'm first going to use a number line to add this one together, okay? I'm going to use a number line. This time I'm not going to have to make a new number line, I promise. I'm going to start with my bigger number, 275. 275. I'm going to add, so I have 134. I'm going to add 100 first. Plus 100. 275 plus 100 should be 375. Same number, just 100 more. So I got that. Now I need to add 30. I think I'm going to start by adding them 10 at a time. Plus 10 is 385. Plus 10 is 395. So 10, 20, one more 10 plus 10 is, well, 395, 396, 397, 398, 399, 400, 401, 402, 403, 404, 405. So at 405, now we just need to add 4. Plus 4 would be 409. I could check my work by adding using standard form, right? 134 plus 275. 4 plus 5 is 9. 7 plus 3 is 10. I put the 0 here, add that 1 up here. 1 plus 1 is 2, and 2 plus 2 is 4. 409. So I now know that Julio has 409 cards. So I can cross this off and write 409. But I want to know their total. So now I'm going to represent the second part of this problem. The second part of this problem, I'm going to use a strip diagram. I'll put it over here. So we have our total, right? The total, which we don't know, but we do know that Julio has 409, and Ben has 134. When I have two parts, we have Julio's part and Ben's part, and we're putting them together, I'm going to need to add if I don't know what the total is, and I only know what my parts are. So I will add 409 plus 134. I'm going to use picture form or pictorial form for this one. Because I'm trying to mix it up, show you the different ways, but pictorial form is definitely the best one if we struggle a little bit with our adding and subtracting. That's why I use it the most, because sometimes we're still working on that in third grade. Sometimes we already have it down and we're ready for things like number lines, we're ready for things for the standard form, we're ready for things like that type of stuff. So let's do this. I have my hundreds, my tens, and my ones. All right, I'm going to make 400. 1, 2, 3, 4. There's no tens in the 409 and 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got this number plus 100. So 100. 3 tens, 1, 2, 3, and 4 ones. 1, 2, 3, 4. All right, now I'm going to add them up. Add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to make another 10 over here. Then I have 1, 2, 3. So I have 3 in the ones place. Now I'm going to add 1, 2, 3, 4 in the tens place. And 1, 2, 3, 4, 5 in the hundreds place. I can double check my work using standard form. 409 plus 134. 4 plus 9 is 13. I bring the 3 down here. Add my 1 to the, add this to the tens place. 1 plus 3 is 4. And 4 plus 1 is 5. 543. My numbers match. Isn't that so great? A couple different word problems using two-step addition. Next week, we're going to mix in some subtraction and do some. We've done two-step subtraction before, but this time I want to do addition with subtraction. So it's going to be super fun. But today, let's look at our objective. I can add what we definitely added using a number line. We use number lines more than once. Pictorial form, we use that several times. And standard form, which we also use several times, to solve two-step word problems. Well, all of our word problems, definitely we had to add more than once, right? We had to add them twice. So we did a great job today. I'm so excited to see y'all next week to go over our addition and subtraction two-step problems a little bit more. Have a great week. Bye!